Welcome to Royal Chemistry Park, the YouTube channel. I am Dr. K. Rajarajan, Associate Professor and Head of the Department of Chemistry, Raja Sarfoji Government College, Tanjavur. In the previous video, we have discussed about the mechanism of elimination reactions. In this video, we are going to talk about the E1CB mechanism. So the E1CB mechanism means it is elimination unimolecular from conjugate base. The E1CB mechanism proceeds by a fast removal of a proton from the beta carbon, resulting in the formation of a carbanion intermediate, which then loses the leaving group in the second slower step. So in the E1CB mechanism, the CH bond is broken first by deprotonation with a base, and the conjugate base of the substrate is produced. Hence, the overall rate of the reaction depends upon the concentration of the conjugate base of the substrate, that is carbanion intermediate, which is accountable for the designation of this mechanism. The reaction is termed unimolecular because the rate determining step involves only a single molecular entity, that is the conjugate base. Here in the screen you are seeing the mechanism of E1CB reaction. So the base abstract a proton from the substrate. So the bonded electron pair between the carbon and hydrogen, it goes to the carbon here, so that you will have a negative charge here. So ultimately, when this electron pair coming to here, the electronic charge of this carbon becomes high, so that it eliminates the leaving group. The leaving group, which is attached to the beta carbon, is getting eliminated, and you will have the double bond here. We can cite the example of a beta hydroxyl carbonyl compound to demonstrate this mechanism. So the beta hydroxy carbonyl compound is number 1, as shown in the screen. So the base abstracts this proton, so that this bonded electron pair is getting shifted to the carbonyl carbon, and it becomes a double bond, so that the already existing double bond is shifted over this oxygen, and here it will have the O minus here. So this double bond, when it is shifted here, the electron density around this carbon becomes high, so that this bond is getting shifted here, so that it will give the structure like this. So the dehydration of alcohols is normally catalyzed by acids. The compound 1 suffers dehydration, that is 1 to elimination, even with acids, but substrates are said to follow E1CB mechanism. The carbanion intermediate rapidly expels OH to form delocalized conjugated carbonyl unit. This is what called as the conjugated carbonyl unit. For elimination reaction to proceed via the E1CB mechanistic pathway, there are two main requirements. Number 1, the compound must have an acidic hydrogen beta to the electron withdrawing group. And number 2, a relatively poor leaving group on the alpha carbon. These are the two main requirements. So, in which a elimination reaction proceeds through a E1CB mechanism. Now let us discuss the mechanistic aspects. So the first step of the E1CB elimination involves the deprotonation of the beta carbon, which results in the formation of an anionic transition state like carbanion. This transition state can be stabilized via delocalization of the electron lone pair through resonance or via inductive effect. The substituents that can stabilize the carbanion intermediate are important. This mechanism is not observed with simple alkyl halides or sulfonates. The E1CB mechanism is only observed when there is at least one good electron withdrawing group adjacent to the carbon-hydrogen bond to be cleaved. The effect of an electron withdrawing group is to increase the Bronsted acidity of the adjacent CH bonds, or in other words, to stabilize their conjugate bases. Hence, it is more likely to be involved when the leaving group is at the beta position to a carbonyl, nitro, cyano, sulfonyl or other carbanion stabilized groups. You see, here this is the leaving group, this is the carbonyl carbon as shown in the screen. So the first carbon adjacent to the carbonyl group is the alpha carbon. The next carbon which is next to the this alpha carbon is this is what called as the beta carbon. So the leaving group connected to the beta carbon is getting eliminated. So the E1CB reactions generally require both carbanion stabilization and a relatively poor leaving group. So in the first step, it is fast reversible deprotonation. It means this base abstracts the proton from the carbonyl compound and ultimately forms this stabilized anionic intermediate. So after that, it undergoes the rate determining step in which the halogen is getting expelled. Now let's see what are the factors that affect the course of the reaction. There are 4 factors, namely the first one is nature of the leaving group, the second one is electronic and steric effects of substituents in the substrates, number third, nature of the base, and finally number 4, solvent effects. These are the 4 effects which predominantly affect the course of the reaction. So different combinations of various aspects which favor any of the limiting types of elimination mechanism can lead to a reaction proceeding with a variant type of mechanism. For example, many substrates containing poor leaving groups such as fluoro, which were originally thought to proceed by an E2 mechanism, may show E1CB like transition state. Now let's see the comparison of the effects of E1, E2 and E1CB mechanisms. As you see in the screen, for E1 reaction, no effect of base sometimes requires strongly acidic medium. And regarding the E2 mechanism, it requires a stronger, bulky and concentrated base which will favor the E2 mechanism. And regarding the E1CB, strongly basic media is required. And now let's see the leaving groups. For E1 reaction, they require good leaving groups. And E2 mechanism, the leaving group must be trans to the hydrogen involved. Then only it favors the E2 mechanism. And the E1CB mechanism, the leaving groups must be poor. Then only it facilitates the E1CB mechanism. And the acidity of alpha carbon. Let us compare the acidity of alpha carbon among the three elimination reactions. For E1, it is less acidic alpha carbon, and for E2, it is acidic alpha carbon, and for E1CB, it is more acidic alpha carbon. And for E1 reaction, the carbocation intermediate involved and the factors stabilizing it. They are the notable features in the E1. Whereas in E2, the E2 reaction proceeds through a single concerted step, and everything happens simultaneously in that step. And regarding E1CB, the carbon ion intermediate is formed here. The conditions stabilizing it favor E1CB mechanism. So we have seen the comparison of the E1, E2 and the E1CB mechanism. So in this video, uh, we have talked about the mechanistic aspects and the factors affecting the course of the reaction and how we could distinguish the E1, E2 and E1CB mechanisms. So the remaining things we will see in the next video lesson. Thank you very much.